Hello, welcome to our final project presentation. My name is Mohan Patnam and I am here with my team members Chen and Bruno Janota. We did this final project so-called Spark Near Real-Time Sentiment Analysis focusing on stock markets as part of Big Data Analytics course with Professor Zoran Djordjevic. Let's get to the project details. We focused on social sentiment analysis in the form of tweets on stock market performance. Just to give a glimpse on what happens these days in the market, take a look at this one. A single tweet by CEO of Tesla, Elon Musk, has made him richer by $1 billion just over the course of the day. That's quite phenomenal. This is another great example to show how social media is playing ever bigger role on the stock markets or in any industry we talk about. In the current political environment, you can see how our president likes to tweet many times often, creating disturbances in the market, whether in a positive or negative manner. It doesn't matter, but he creates impact through his tweets on the specific industries he's targeting. One could argue these are celebrity roles in their respective fields, and so their tweets will certainly have impact on the respective markets. But how about the social sentiment by hundreds of users, thousands of users in a collective fashion when they talk about specific products, services of various industries? What effect do they create on the respective markets? We'll go through that through our project. Now let's get back to a little bit basics on what actually drives stock prices. We all know there are fundamentally two things. Number one, the fundamental factors, which basically looks at the bottom line of the company's performance, like balance sheet, earnings, and growth. Number two, the technical factors, which is more driven by macroeconomic events, like the performance of economy, inflation, and geopolitical factors. And finally, the more interesting topic for the evening, does social sentiment matters, like tweets in particular? That's a focus of our project. Appears social sentiment does matter. However, be aware of noise, fake news, and day-to-day gyrations with these social media tweets. If you could find a way to effectively filter these factors, then we could probably think of social media tweets as an electronic word of mouth. Stretching it further, could it even be a leading indicator of stock prices? That's something to investigate. The main data source for our project comes from this popular social media platform called stocktweets.com, where investors, traders, and general public alike, they go and comment on specific companies' products and services, and they could even tag specific tweets, whatever they are posting, with a sentiment category, what they feel about that tweet. Like in this case, you can see an example of a bearish tweet on Apple stock posted by a particular user on recently, right, May 7th. And so this is a great source of data for one to process and see if there is any valuable information that we could derive out of. Let's get to the project statement and scope. This project basically examines whether social media feeds focused towards stock market and concerning companies are a suitable data source for forecasting the direction and volatility of the underlying stock prices. We did a case study of 3 most popular stocks: Apple, Facebook, and Tesla by collecting their historical tweets from stocktweets.com platform. We built a methodology to build sentiment scores using a couple of approaches, as you can see here, and we also did a bit of regression analysis to predict the stock volatility or changes in underlying prices using sentiment score as a predictor. There are 5 phases to this project. We began this project by providing a generic approach to download historical tweets for the chosen stocks for a period of 2 months, and we then introduced a couple of models to calculate the social sentiment scores. The first approach being bag of words approach using 2 popular dictionaries, and the second approach using a probabilistic model called the so-called naive Bayes classifier. We applied basic text processing techniques using NLTK to pre-process these tweets using the lemmatizer and stop words concepts. We further performed regression analysis to see if social sentiment scores can predict the changes in the underlying stock prices. And more important, we demonstrated an ability to sense the market pulse or sentiment using a near real-time streaming of tweets. And we did this using the Spark streaming package. Our aim, to emphasize again, is illustrate the use of modern machine learning and real-time processing techniques while answering a fundamental question of whether social sentiment matters for stock market performance. The biggest challenge for any big data project is how do we collect the data. Many times the data is highly unstructured and not very suitable for direct processing. Now, getting to specific data sources that we use for this project, there are fundamentally 3 of them. Historical tweets from StockTweets platform, historical stock prices from Yahoo Finance, and Bloomberg intraday prices for specific stocks. As far as the stock tweets goes, they provide a RESTful API with JSON responses, and we basically automated that whole process to derive CSV files with structured data out of the JSON responses.
As many of you may know, working with unstructured text data can be a fairly arduous process. Pre-processing is necessary to create more accurate and reliable models. We employed several methods, starting with removing stop words using the NLTK corpus. Then we created a custom function to remove hyperlinks, mentions, and other non-essential words. Next, we used NLTK Perceptron to tag the remaining words for their parts of speech and keeping only nouns, verbs, and adjectives. Following the part of speech tagging, we used the NLTK WordNet lemmatizer to combine identical words of different tenses to reduce dimensionality and improve frequency counts in our final dataset. Lastly, we removed duplicate tweets that may be spam and empty tweets as a result of the pre-processing steps. So this is an example of one of the tweets in our dataset before and after pre-processing. As you can see, the after tweet gives us a much cleaner representation of the words in the original tweet, and when you do this over thousands of tweets, you can create a more robust dataset that allows you to properly weight bearish and bullish words.
Our first approach is to implement a bag of words dictionary model to score tweet sentiment on a scale of -1 to +1. Once a list of words are cleaned up, each word is classified as positive, negative, or neutral based on a lookup dictionary. The sentiment score for a single tweet is the number of positive words minus the number of negative words divided by the total positive or negative words. So for example, if there are 2 positive and 1 negative word, it gets a score of 0.66. For daily totals, we calculate the average sentiment score across tweets that day, and the frequency of tweets is also given some weight. The most commonly used dictionary for word classification is the Harvard Psychosociological Dictionary, or Harvard IV4 Tag Neg. We used an updated version of this dictionary here. Also, in a 2011 paper, two professors at the University of Notre Dame, Tim Logren and Bill McDonald, found that the Harvard Dictionary substantially misclassified words when gauging tone in financial applications. So our second dictionary that we use here is the Logren-McDonald Dictionary, which we also refer to as the Financial Dictionary. Notice there's an imbalance of the number of positive words compared to negative words in the Financial Dictionary. In the Harvard Dictionary, it's a little bit more balanced, but also still skewed. In the chart at the bottom, there does not seem to be much of a correlation between bag of word sentiment and daily returns over the 2-month time period. To test model accuracy, we relied on bullish or bearish tags that are appended to many tweets on StockTwits. Using the set of all tweets that had these tags, we checked how our bag of words dictionary model worked against it. We found that the Financial Dictionary did better overall, with 72% accuracy compared to 65% on bearish, and on bullish it was 54% compared to 51%. One area the Harvard Dictionary performed better on was making twice as many predictions as the Financial Dictionary. This was due to having more words in the Harvard Dictionary. Many of the tweets had no words labeled positive or negative, so they were not included in the confusion matrix. We also looked at how prices moved intraday. We calculated the cumulative score for sentiment between 9:30 a.m. and 4 p.m., which is when markets are open. In green and blue, we provide the sentiment scores, and red is the price. So you can sort of see that between the Financial Dictionary and the Harvard Dictionary, the financial one does a bit better, but the fit is still not great. Our last application of our bag of words model was to apply Spark streaming. So we simulated real-time feed using historical file, and we sent messages as they in batches, having Spark compute the sentiment scores on the fly. This is a chart of cumulative scores as they come in. Notice that the blue line closely matches with the blue line of the previous slide, as it's the same data set.